Welcome to the second part of um, types of programming. So we will discuss the compiler and interpreted programming language, or compiled and interpreted programming language. So we'll start this as usual with the metaphor. Here's the metaphor for the compiled and interpreted programming language and intermediary as well. So these are just a way of describing this programming language because they are so hard to define. So we're gonna discuss the uh, nuance on how it's described in computer science. So for compiled programming language, you need this diagram here, source code, whether it's like um, Java, types of like C. Let's search types of types of compiled. So basically, the compiled programming language use compiler to compile it to an executable machine code. Um, an interpreted programming language use a interpreter here to translate it to machine code. The metaphor for that is that imagine let's see, a professional chef cooks your entire meal in the restaurant's kitchen. So that is the compiled programming language. The chef cook it and then just serve it to you. For interpreted programming language, is instead of a pre-cooked meal, the chef arrives at your home with raw ingredients and cooks everything step by step in your kitchen. You get the dish fresh, but the chef, the interpreter, has to be there every time you want the meal. So in programming terms, the source code is read and executed line by line by an interpreter on your machine. You never get a fully pre-cooked file. Every run needs the interpreter presence. So first, the instructions defined in the source code are translated into a sequence of instruction for the computer. So it instructed the computer step by step. So that's actually what happened when we use programming language. We compiled it and then the compiler translate it to instructions using the machine code, which is one and zeros. You must compile a separate version of the program for each operating system. So here's the diagram for that. Here for C++, this is an example of you can compile it to Windows and then Linux or Mac OS. Programs compiled for a specific operating system are also called native programs or native applications. Interpreted programming language, the source code is not translated by a compiler, but is instead analyzed by an interpreter. So, like what I've said, it's interpreted by the interpreter. The prerequisite example of this, guys, is a JavaScript. You need a Google Chrome to run this. So the interpreter needs or the runtime is needed for the code to run. Another example is Node.js. You use Node.js to run JavaScript. So the prerequisite of this is, of course, the interpreter must be implemented on the or available on the computer in which the program is executed. So for most computers now, browsers is available, right? Because that's the most useful. Um, apps, one of the most useful apps. Compiled program does not require a compiler to be installed on the operating system on which the program runs. So for compiled programs such as C++ on Windows, since you compiled it beforehand, like a chef cook it beforehand, you don't need all the ingredients. You don't need all the ingredients at home because it's already cooked. So let's say you want to change something on the flavor, you want more spicy, you need to create a new version like this for Linux or Mac OS. Compiled programs does not sorry, examples of compiled program does not require a compiler to be installed on the operating system on which the program runs. Yeah, we've discussed examples of interpreted programming language include PHP, which is in the chapter 15 or video 15 we will discuss, Perl, Python, and my not video 15, topic 15, and my personal favorite, JavaScript. Yeah. Interpreters or runtime environments which contain interpreters for JavaScript, for example, can be found in every browser. So like what I've said, it's the most one of the most useful apps, so you can get away with that. Intermediate language. So intermediate language is kind of like a bit of compiled and a bit of uh, interpreted. So imagine a chef where it pre-cooks the meal in a way, but it needs some finishing on the customer's house to complete the meal. So it's done the work or it made the work beforehand. So a lot of the work are made beforehand. It's like Java here. For Java, you have the source code, you compiled it using the build that Gradle for Eclipse. We will discuss that in the next videos. And then it's converted to bytecode. And then for the finishing touch, you need an interpreter to convert it to machine code. Programming paradigm. So this is another way to describe this programming language. It's the usual way to describe these languages is imperative and declarative programming. The first, we will discuss type of imperative uh, programming. So first one is structured programming. The crucial difference from the basic principle is that this programming paradigm uses control structures such as branches, if, else, and loops do while instead of absolute jump instructions. So it used to be that you do the programming by jumping through instructions. So that's way like 50 to 60 years ago. But for this structured programming, you use if else statement um, to implement the code. So the metaphor for that is like imagine a city like this, implementing a city. Imperative programming, it's like building a city with a strict city planner who writes down every single instruction for constructing roads, bridges, and buildings. You specify exactly how each structure must be built, brick by brick. This is similar to languages like C or Pascal, where you command the computer in every little detail. And then declarative programming, the comparison of that in city is like telling an architect, I want a vibrant, green, and efficient city, and then letting the architect design and build it. Here, uh, you focus on what the end result should be rather than the step-by-step process to get there. So, example is SQL or HTML, where you describe the desired outcome without dictating every construction step. So first, the structured programming. We've discussed that, but another metaphor for that is that within this city, structured programming is like organizing the construction into well-defined districts using roads, bridges, and landmarks instead of random detours. It uses control structures like loops and conditionals instead of chaotic jumps. Procedural programming, it extends the imperative approach with the possibility to divide algorithms into clear sections, that is, into function. It's like breaking the project into distinct tasks or phases, much like assigning separate teams to build different sections of the city. Each task or function is handled individually and can be reused elsewhere. Modular programming is similar to procedural programming, but additionally allows source code to be divided into logical, independent, and reusable modules. So this takes even further by dividing the city into the independent, self-contained modules like neighborhoods that can be developed separately and then combined to form the complete city. And then lastly, the most useful, object-oriented programming, often OOP. It's based on the concept of objects which manage data in the form of fields, also attributes or properties, and code in the form of procedures or methods. In simple terms, methods are functions that belong to an object. So here are the diagrams for the JavaScript source code. It's the interpreter for different operating systems. Um, uh, yeah. So for object-oriented programming, uh, it's akin to using blueprints for different types of buildings. Each building or object is created from a blueprint class that defines its common features. Yet each instance has its own unique details. So what it meant is that, like, remember when we're creating like a like this a blogging website, the classic blogging website. Sorry, wasn't able to share that out. But let's say the delete button feature, it's actually a class in object-oriented programming. That's an example of a class. Inside it has services, right? It could have different services that has its own unique details because those instances has different like properties. So yeah, the principles of abstraction, encapsulation, inheritance, and polymorphism work together in this classes or in this blueprint. Later, we will discuss the distinction of class based object-led programming and prototype based object-led programming. But the abstraction, the we will discuss that in detail. So the most useful programming language that are used today are uh, defined as object-oriented and functional programming. And then for declarative programming, in a logical programming language like Prolog, you define a set of facts and rules that describe the relationship between symptoms and potential problems. For instance, you might have this example like this code. So you have a rules, you state the facts, symptoms, and then you have the rules. So if the system recognize this these symptoms, it decide based on the rules. So you define that what's the rules, and then the system operate based on that. So this kind of program thrive on like like scheduling for or like this diagnosing or planning any program that relies on those functions thrive using those type of programming language. Functional programming is a programming paradigm in which programs are created by applying and composing functions. In functional programming, functions are treated as first-class objects, that is, they can be passed as arguments to other functions, like objects or other data types, or returned by other functions, for example. So JavaScript is a combination of object-oriented programming and functional programming. That's why it's one of the most useful because functional we use functional and object or oriented programming mostly today. And then we'll go to object oriented programming here. Mhm. Principle 1, abstraction. Classes are therefore referred to as abstraction of the actual object instances. Um, the way or the comparison here or the metaphor would be the blueprint outlines what a building is without showing every brick. So imagine on the city, building a city metaphor. If object-oriented programming is akin to using blueprints for different types of buildings, then one of its principles outlines what a building is without showing every brick. So in this metaphor, this building. You create this building in object-oriented programming without showing every brick. And then the next point is the classes define the abstract behavior. That is the behavior that is common to all object instances, as well as the properties that are common to all object instances. So in the delete button feature or create post feature of my blogging app, you define the behavior that is common to all object instances. So remember we separate objects that has different uh, that is has different properties or it's not really related to each other. So that is an abstraction as well. In object instances, the properties are then provided with concrete values, thus defining the concrete state. So inside those classes or blueprint, there is an object instance that has the properties provided with concrete values, thus defining its concrete state. These diagrams are common in software development. Here, this diagram, one of the best way to explain that. So here's an abstract, and then this is the concrete values. So these are called UML, Unified Modeling Language. These diagrams are common in software development to represent classes and the relationships between classes. And then principle two, data encapsulation. The term data encapsulation, also encapsulation or information hiding, is used in object-oriented programming to describe the grouping of properties and methods into classes when the details of the implementation remain hidden. So the inner workings like the plumbing and the wiring are hidden away when you interact with the building on this city. And then you interact on this building on the city only through its doors and windows, which is methods. So another point is that accessing properties of an object from outside the object should only be done via methods, not directly through the properties. So this way of building cities, um, rely on methods, right? Or sorry, yeah, methods to access those properties. For this purpose, developers often implement certain access methods called setter and getter methods to change setter or query getter the value of a property. One advantage of setter methods is, for example, that the validation of past values can take place within the methods, and thus you can avoid having invalid values assigned to a property. Let's see. Okay, so it's kind of this kind of like hard to explain, but the validation can take place within the method. So yeah, this is the metaphor for this to better understand it, because for every like hard concept, there is corresponding metaphor that allow us to understand it. You know, if it's hard for us, we can always find metaphors that allow us to understand it. So data encapsulation is like keys, right? Sorry, keys or windows to your diary. So instead of having anyone like change your diary or access it, you have access methods or keys, and then windows. Like imagine a windows in the room where you need to put a password before you can access this diary. So that's kind of like the metaphor for this encapsulation. So here, this point, yeah, developers often implement certain access methods called setter and getter methods. So that this is the piece, the setter and getter methods to change setter or query the value of the property, the value of that notes on your diary. One of advantage of setter method is, for example, that the validation of the past values can take place within the method, and thus you can avoid having invalid values assigned to a property. So the efficient thing about this city or this this city is that instead of having anyone own the building, have access to wires or pipes, you need a certified electrician or people who knew what they are doing about the electricals and the plumbing to change it, because those information or those details are actually important for the structure of the city. For example, another point is that you can use this method to prevent a negative number from being set for a property that requires a user's age, or avoid a string that does not represent a valid email address from being set for a property that holds a user's email address. So let's say you have a form that requires an email address. You want that form to avoid any format that's not like like an email. And then for age, you don't want the age form to be negative, because that's not proper. Okay. Principle three is inheritance. Classes can inherit properties and method from another class. The parent class, also superclass, transmit one or more properties or methods, while the child class, also subclass, inherits one or more properties or methods. Dog class could be derived from an animal class and thus inherit properties and methods defined in the animal class. So this is an example of that here. For animal, for here, let's see. Here for animal, you can access it using the method setName, Bella, but you cannot access it directly using color. Another metaphor here is that Hmm. I think that's not that hard concept to understand the parent because we have that discussed that. So we'll move to the here. Here's the diagram. Cat inherit from animal. Dog inherit from animal. We'll move to polymorphism. Okay. The ability of objects to adopt another type, another shape, or to represent themselves as other type, depending on the context. So, for metaphor on our building a city, polymorphism, imagine this like different buildings may serve similar purposes like hotels or apartments, both providing shelter, but in their own unique way. Another metaphor is this, which I searched in Gemini, which is I think good example. Imagine you're a pet clinic. You have a checkup routine, which is your method. These routines work for any animals. You don't need to know if it's cat, dog, or bird. You just need to have a list of those animals, and then you have this method check up for each routine. Another example is a gas or a vehicles metaphor. The refuel action is polymorphic. It works for all vehicles, but the specific fuel type varies. Shape, another metaphor is shape. The draw action is polymorphic. It works for all shape, but the specific drawing method varies. Employees, the pay action is polymorphic. It works for all employees, but the calculation varies. So that is another way to explain this polymorphic. So again, we're trying to create or provide different explanations, especially for complex concepts. That's why this computer science has this abbreviations or descriptions for this to define the nuance because without words it's really hard to understand how things are different or the little nuance that differentiate the different programming languages. And then lastly, again, as I promised, we will discuss the difference between class-based, object-based, and prototype-based programming language. An example of class-based programming language is Java. In contrast, an example of object-based programming language is JavaScript, where object instances are not created based on classes, but based on other objects. These are the objects that represent prototypes. So we'll start with prototypes. For prototypes, object instances are not created based on classes. It created based on other objects. So JavaScript may look like it's class-based because classes have been defined since 2015, but objects actually defined based on other objects, which called prototype. That's why it's called prototype-based programming language. So it's another way to define this language. Java, on the other hand, is an example of class-based programming language because it base its object instances or the services inside those delete button feature or create post button feature of my blogging app are based on classes, not on other objects. That's why it's called class-based programming. And again, guys, thank you for watching. And to sum it up, we discuss the different ways to discuss programming language, including compiled and interpreted programming language, imperative and declarative programming language, and then we're now discussing the most useful type of programming language, which is object-oriented programming. So the principles of abstraction, encapsulation, inheritance, and polymorphism works like designing a city efficiently, right? So again, thank you for watching and see you on the next video. Peace.